go over and push both of the switches at the same time, and now this is what will happen. Hello and welcome back to Sci-Fi Tech. In this video I'm going to show you how to take a 555 timer, an LDR, and an auto-changing RGB LED to create a noisemaker. Let's get started. And these are the items you're going to need to make for this project. The items you're going to need: a 9-volt battery, a 9-volt battery clip, a Perfboard, an auto-changing RGB LED, a shrink tube, a 1K ohm resistor, an LDR, a 3-volt button cell battery holder, a 3-volt button cell battery, 2 slide switches, an 8 ohm 1 watt speaker, an 8-pin IC socket holder, a 555 timer, which will be the brains of the device, a 1 microfarad electrolytic capacitor, 2 neodymium magnets, and some cardboard. And you're also going to need some wires. And this right here is the schematic that you're going to need to follow to make for this project. And this schematic was originally used for a 555 timer mono LDR theremin. And the only modification that you need to add to the circuit is simply the auto-changing RGB LED and placing in front of the LDR. And then simply take a shrink tube and covering it. Doing this will create what looks like an optocoupler. Now let's go and assemble this project and let's get started. First, I want to take the auto-changing RGB LED, take the 3-volt button cell battery, place it in, and now I know which pin is the anode and which pin is the cathode. And the idea is I want to take the auto-changing RGB LED and take the LDR and place them together just like this. And then take a shrink tube and place it over it, so that way the LDR can only receive the auto-changing RGB LED light. Next, I'm going to take the 8-pin IC socket holder and place it into the Perfboard. Place it in just like this. Clamp it down. Solder in only one pin. And as you can see, it's not flush with the board, so what I need to do is take my thumb, press down on the IC socket holder, remelt the solder, and there, it is now flush with the board. Next, solder the rest of the pins in place. Next, I'm going to take these 2 wires, take one wire, connect to pin 8 over to pin 4, and then pin 2 to pin 6. Solder the wire to pin 8, and now solder it to pin 4, and there, pin 4 and 8 are now connected. Take the second wire to connect to pin 2, and then connect it to pin 6, and there, pin 2 and 6 are now connected. Next, take the 1 microfarad electrolytic capacitor. This side's negative, this side's positive, negative goes to pin 1, positive goes to pin 2. Place it in just like this. Bend over the leads. Solder it into place. And now solder bridge it together, connecting the positive over to pin 2 and the negative over to pin 1. Next, take the 1K ohm resistor and connect it to pin 8 and 7. Bend over the leads. And now solder it into place. Cut off the excess. Make some adjustments. And then solder bridge it and connecting pin 8 and 7. Next, take the LDR and connect it to pin 6 and 7. Place it in, but be careful, don't go all the way because I want a little bit of excess wire. Bend over the leads, solder it into place, and solder bridge it to pin 6 and 7. And there should look just like this. Next, I'm going to take the 9-volt battery clip, and I'm going to connect the positive over to pin 8 and the negative over to pin 1. Place it in, clamp it down, bend over the lead, solder it into place, and solder bridge it over to pin 8. And there, the positive is connected to pin 8. Take the negative wire, place it right here next to pin 1, clamp it down, bend over the lead, solder it into place, and solder bridge it over to pin 1. And there, the negative is now connected to pin 1. Next, I'm going to take these two wires and solder it to the speaker. Solder it into place, just like this. Next, take one of the wires from the speaker, place it next to pin 1 to ground it. However, polarity in a speaker doesn't matter. Bend over the lead, solder it into place, and solder bridge it over to pin 1. And there, the speaker is now grounded. Next, take the second wire from the speaker and place it next to pin 3. Bend over the lead, solder it into place, and solder bridge it over to pin 3. Uh-oh, add a little too much solder, so pin 2 and 3 are connected. I need to fix that. And there, now it's fixed, and it should look just like this. Next, take the 555 timer and place it over to the 8-pin IC socket holder. Place it in just like this. And there, the circuit is now complete. And there, this part of the circuit is now complete. Let's go ahead and test it out. Plug in the 9-volt battery, and now it should be noisy. There, and as you can see and hear, it works. And now it's time to create the auto-changing RGB LED circuit. Next, take the 3-volt button cell battery holder. This side's negative, this side's positive. Place it right here, just like this. Clamp it down, solder it into place. And now take a positive wire and place it right here next to the positive terminal of the 3-volt button cell battery holder. Clamp it down, bend over the lead, solder it into place, and solder bridge it to the 3-volt button cell battery positive terminal. Next, take the negative wire and place it next to the negative terminal of the 3-volt button cell battery holder. Clamp it down, solder it in place, and solder bridge it to the negative terminal. Next, take the auto-changing RGB LED, solder the cathode over to the negative, and then the anode over to the positive. And there, she'll look just like this. Small problem, you can see the LDR is a little bit too long and is causing the LED to not cover it properly, and will make the circuit stick out too far. So what I'm going to do is solder the LDR leads over to the solder pads of the Perfboard, just like this. Take some flush cutters and cut off the leads just like this. And now take the LDR, shorten the leads just like this. Solder tin it. And now solder the LDR back into place. Next, take the shrink tube, place it over the LED. Next, take a dab of super glue, place it on the LDR. And now glue the LED to the LDR. Glue it into place, spray some kicker, wait for it to cure. Next, take some more super glue and place it over the exposed leads. Doing this will keep everything insulated. Cut off the excess glue. And there, the exposed leads are now insulated. Next, take the shrink tube and place it over the LDR and the LED. Next, take a heat source and shrink the tube. And there, she'll look just like this. The LED light is now insulated. Now, let's go ahead and test it out. Take the 3-volt button cell battery, place into the 3-volt cell battery holder. And if you look carefully inside, you can see the LED is flashing. And now it's time to plug in the 9-volt battery, and then the 505 timer with the LDR is going to react to the flashing of the LED, which is going to make a lot of interesting weird noises. Now let's go ahead and test it out. Careful, this is going to be very loud. And there, as you can hear, it works. Now I cut the wire because what I need to do is I need to connect these switches. I need to connect the switch to be able to turn the circuit on and off. And you can see that the LED is still flashing inside, so I need to do the same thing right about here. I believe cutting it right about here is good. There, as you can see, the circuit is now off on both circuits. So now I can take the other slide switch, attach it to these two wires, and this slide switch attach to these two wires. Next, remove the insulation on all of the positive wires. Solder tin it. Solder tin the slide switches. Next, as an option, cut off the unnecessary pin of the slide switch. Next, cut off the excess Perfboard. And there, she'll look just like this, and I'll take the extra part of the Perfboard and save it for another project. Next, take some sandpaper to smooth out the Perfboard. And there, it is now nice and smooth. And now it's time to build the housing for this project. Next, take a generous amount of hot glue and put it on the back of the circuit. And now take a piece of cardboard and place it on top. Doing this will protect the circuit and keep it insulated. Next, put a little bit of hot glue in the center of the cardboard. Next, take the neodymium magnet and glue it into place. Wait for the glue to solidify, and there, it should look just like this. And now I can take the 9-volt battery and stick it onto the magnet. And the idea is to take the 9-volt battery, put it on top of the speaker because the speaker is also a magnet, and then take the circuit and put it on top of the 9-volt battery, sandwiching the two parts together. That way everything stays in place. Next, take the piece of cardboard, put it on the side of the speaker, glue it into place, and this will be one of the sides of the housing. Glue it into place. Make sure it stands up perfectly in a 90-degree angle. And there, it should look just like this. Nice and flush with the speaker and nice and flush with the table. Next, repeat the same process 2 more times. And there, this side is glued into place, and you can also see that I put some hot glue on the corners of the 2 pieces of cardboard, so that way the 2 pieces of cardboard are glued together. Move the circuit to the side, and then repeat the same process with the 3rd piece of cardboard. And there, it should look just like this. Next, take the smaller piece of cardboard, place it right here, and then take some hot glue and put it on 3 sides of the cardboard. Lift it up and glue it into place just like this. And as you can see, this piece covers the speaker. And now I can take the 9-volt battery, place it in, and it will allow me to be able to take the 9-volt battery in and out. And I'll take the circuit, put it on top. Put everything into position. And now take another piece of cardboard, and as you can see, when I take this piece of cardboard, I can slide it underneath perfectly, which means this will be the opening of the housing. Goes in and out just like this, tucked underneath the speaker in the cardboard, so that way it can be able to slide in and out easily. To make it extra secure, I have this piece of cardboard that I want to glue into place. Put some hot glue going across like this, and then take this piece of cardboard and glue it into place. And this piece of cardboard right here will be the security piece that will secure this piece of cardboard, so that way this piece of cardboard doesn't fall out. And now take the top part of the housing, goes right here, just like this. Take a little bit of hot glue, place it onto the cardboard. And then take this sliding piece of cardboard and glue it into place. And then take this piece of cardboard and glue it to the top part of the housing. Make sure that it's glued in a perfect 90-degree angle. Hold it into place and make sure it stays in 90 degrees. Wait for the glue to solidify. To make sure that it's in a perfect 90-degree angle, I have right here a sandpaper block, which is a rectangle which has 90-degree angles. Place it in just like this, and as you can see, it's a perfect 90-degree angle, which means it's glued together perfectly. And the idea is I can take this part of the housing, put it in just like this, and the top part of the housing covers the circuit. Next, carefully take one drop of super glue and place it onto the slide switch. And now glue the two slide switches together. Make sure they're perfectly aligned, and it should look just like this. Next, what I want to do is take a drill and drill a hole through the two switches, so that way I can take this wire, slide it through the hole, glue it into place, so that way the two switches can turn on and off at the same time. Next, I'm going to take the slide switches, and I'm going to take these wires and solder it to the first slide switch. And there we go, the first switch is soldered to the LED circuit. And now solder the second switch over to the 555 timer circuit. And there, the two slide switches are now soldered into place, and it should look just like this. Next, I'm going to take the slide switches, I'm going to put them right here, cut it about the same size as the slide switches. Next, take the slide switches, put them into place. And there, it goes in just like this. And there, as you can see, it's a perfect fit. Next, take some hot glue and glue the switches into place. And there, it should look just like this. Next, take another neodymium magnet, place it on top of the slide switches. Sticks right there, just like that, because it's attracted to the slide switches. Place a small drop of hot glue on top of the neodymium magnet. And now take the top part of the housing, glue it to the neodymium magnet, and put it into place. And there, it should look just like this. Now, the neodymium magnet will hold the top part of the housing into place, and I can be able to remove the top part of the housing, just like this. And as you can see, it opens and closes just like this, and it also stays in place very well. And as you can see with this design, I can easily change the batteries. The 3-volt button cell battery can easily be changed, and so does the 9-volt battery. And now to make it look a little nicer, I'm going to take a piece of cardboard and put it on the bottom part of the housing, covering the sides of the speaker just a little bit. And now take the housing, place it on top, make a mark so that way I have an idea where to cut. Cut out a perfect square. And there, it should look just like this. Next, take a measurement of the diameter of the speaker, and the solder wick spool is the same diameter of the speaker, which is the perfect size. Next, what I need to do is draw an X on this piece of cardboard, so that way I can find the center of the cardboard. And as you can see right here, X marks a spot, and this is the center. And now take the solder spool, and place it perfectly in the center, just like this. Trace around the solder spool, just like this. I've right here a perfect sized circle that is now centered, and now simply cut it out. And there, it is now cut out. And now I can take this part of the housing, place it on top, and as you can see, this looks a lot nicer. Next, take some hot glue and put it on the perimeter of the housing. And now glue the bottom piece of the cardboard into place. Next, take some scissors and cut off the excess cardboard. And as you can see, this looks a lot nicer. And now it's time to test it out. Let's have a listen and hear what it sounds like. Go over and push both of the switches at the same time, and now this is what will happen. And as you can hear, it's a very noisy box. Very loud, noisy, and very annoying. And there you have it. Now you know how to make your very own noisemaker with using a few simple parts such as a 5x5 timer, an LDR, and an auto-changing RGB LED. Thank you for watching Sci-Fi Tech. I hope you learned something new, and don't forget to like, share, and subscribe, and of course click on the bell icon to be notified of future Sci-Fi Tech videos. To the next tech, goodbye.